400 million. That's the number of wooden utility poles in service today in the U.S. Alamon Contract Services is revolutionizing the process of inspecting and evaluating the serviceability of these poles, providing non-destructive testing that yields far more accurate results than ever before, compiling data that is accessible via any web-enabled device.
We pull a graph out of that pole and we record that graph. It's available to the customer on a website forever.
And reducing time and labor costs to a fraction of traditional inspection methods.
An inspector can walk up to the pole, do a visual, do some sound test, drill the pole, and walk away in under 10 minutes.
Alamon's superior inspection technology is a welcome advancement for an industry that has long relied on relatively primitive and subjective testing methods.
Typically in traditional methods of pole inspections, the companies will have their inspectors pull away dirt from the base of the pole to inspect the integrity of the pole. When that happens, you're pulling away a base layer of protection from the pole.
It removes creosote, copper, chromium, arsenic. It removes all that protection that was injected into the pole from the soil around it.
So if you don't have to disturb that, you're better off. But if you do disturb it, you almost got to treat it because you're going to saturate the ground again the same fashion.
The other part of their inspection program would involve having a larger bore drill bit go into the pole. The inspector would then physically look at the sawdust in the pole and make a determination whether that sawdust is rotten wood or good wood. Look at it, sniff it, crumble it up.
Not only does the traditional drill test rely on a subjective interpretation of wood shavings by the inspector, it also samples only half the pole, and does so destructively, removing wood from the pole and inviting insect infestation and rot. Alamon knew there had to be a better way, and it started with the resistograph.
We tried pretty much everything that's out there, but the resistograph is the only device where you can test below ground and get accurate information.
The advantage of the resistograph is that it uses a pencil lead-sized drill bit drilling into the base of the pole below ground at a 45-degree angle. And it spins at 5,000 RPMs, and as it encounters good wood, it encounters more resistance, which registers on the graph on the machine. As it hits rotten wood, there's less resistance on the spin of the drill bit. The wood's not good, the bit's spinning a little bit faster. Another advantage of using the resistograph and the small drill bit, it can extend through the entire width of the pole. And when you do that on multiple coordinates, you get a clear picture of what the internal structure of that pole is.
With a visual sound prod and using a resistograph, you're going to do all the things the same as the rest of the people. Plus, we're going to look at the whole pole at ground level to 18 inches down. As we drill through the growth rings of that pole and record that, we see how much of that pole is good, how much is bad, how much sheath there is, and it's defined by the drill, not by the person doing the drilling.
As reliable as the resistograph is for gathering information, Alamon knew there was still one more step to take to truly establish an industry-leading pole inspection process.
Alamon has created a software that matches up with the IML drill series. It's customer specific. It gives the customer as many options as they possibly want as far as how to GPS their poles, what the condition of the poles are. We can do inventories on the attachments of the poles, whether it's power, cable, TV. Basically anything that a lineman from the power company or telephone company would walk up to a pole and say, XYZ is wrong. We have a software program that would register that, automatically update their database, and alert an engineer that they have a problem in the field.
The core of Alamon's software is a proprietary algorithm used to evaluate the condition of poles. Based on RUS Bulletin 1730B-121, which sets industry guidelines for pole inspection, the algorithm determines the condition of poles with remarkable accuracy. Here's how it works. The resistograph drills the pole and collects data. The data is transferred to the handheld device via Bluetooth. Alamon's algorithm analyzes the data and evaluates the pole. The results are then uploaded to the customer's database. The Alamon process has moved utility pole inspection out of the dark ages and into the 21st century.
We pull a graph out of that pole and we record that graph. It's available to the customer on a website forever. Well, we come back, we test that pole 5 to 10 years, whatever their cycle is. We can pull a graph 10 years down the road, nail it against the graph from 10 years ago, and they can see the progress, what's going on with that pole.
We are able to give accurate information for less cost. An inspector can walk up to the pole, do a visual, do some sound test, drill the pole, and walk away in under 10 minutes. So that labor cost, combined over thousands and thousands of poles, is a huge money saver for our customers.